In this video, we are going to look at the metric system. So let's take a look at an example. We want to talk about how far of a distance it is from Auburn to San Antonio. In miles, it is 2,160 miles approximately. And that's generally what we're talking about when we're talking about traveling. However, if we wanted to, we could convert this into feet. We have a conversion factor that says that there's 5,280 feet in 1 mile. Miles cancel. We're left with feet. And if we do the multiplication, we see that there are 11,404,800 feet from San Antonio to Auburn. Now this number is quite large, so that's generally why we're going to report it in miles rather than feet, because this is an easier number to deal with than this one. So this isn't the metric system. This would be the U.S. customary system. Now let's take a look at the metric system. Instead of dealing with miles for distance, in the metric system, we tend to deal with kilometers. So from Auburn to San Antonio, instead of 2,160 miles, we would say there is 3,476 kilometers. And we're talking about the distance between two places. So this number and this number, they're the same. It's just that they're expressed with different units. And let's say rather than expressing it in kilometers, we wanted to express it in meters. There's a conversion factor for that. There are 1,000 meters for every kilometer. And when we do that calculation, we see that there's 3,476,000 meters to San Antonio from Auburn. Now, the reason why I did this in the U.S. system and then the metric system, and I convert it from one unit to the other, is because I want you to pay attention to how the number changes. So of course these are two totally different numbers, but they're not even similar in the fact that this starts with a 2 and now this one starts with a 1. If you look at the metric system, we had 3,476 kilometers. Now we have 3,476,000 meters. So you'll notice, yes, the numbers are different, but all we've done is added zeros to this number. So the really nice thing about the metric system, so the second example here, is that it's all based on tens. So what we're really doing is just taking a number, so 3,476, and we're moving a decimal place. So our decimal place is here, we're moving it, in this case, 3 this way, and adding in zeros. So the metric system is all based on tens. It makes it much easier to work with than the U.S. system. The U.S. system, the conversion factors here are not based on tens. So you're going to get totally different numbers, which is fine, but the problem comes in that there's all of these different conversion factors that you have to know or be able to access. With the metric system, once you learn how it works, all the conversion factors are based on 10. So this is 1,000, which is 10 times 10 times 10, or 10 cubed. Let's take a look at some more examples. A nail head is 0.007 meters across. So a nail head is pretty small. We typically wouldn't really report it in meters. In the U.S. system, that would be like reporting the size of a nail head in feet. We generally wouldn't do that. We want to know, what is this in centimeters? So there are 100 centimeters for every meter. And when you do that multiplication, we see that the nail head is 0.7 centimeters across. And another way you can do this, you don't even have to type this into your calculator. If you're multiplying by 100, that's 10 times 10. You're going to be moving your decimal place 1, 2 to the right. I know it's to the right because I'm multiplying by this number, and if we wrote that in exponential form, it would be 10 squared, and my exponent is positive. We'll get into that more later. Okay, let's look at a second example. A red blood cell, so we're talking really tiny, has a diameter of 0.000008 meters. What is this in micrometers? So this is a Greek symbol, it means micro. And there are 10 to the 6th, 1 million is 10 to the 6th, micrometers in 1 meter. So I need to move my decimal place 6 to the right. 1, 2, 3, 4, 5, 6. So 8 micrometers. And if you wanted to check on that, you could do this number times 1 million or 10 to the 6th, and you'll see that you end up with 8. So you might be wondering, how did I know this conversion factor and this conversion factor? And how I knew that was with this table. Now this table, it looks like a lot when you're first taking a look at it, but there's really only 2 components to it. So right here, these first 2 columns is a prefix, and then what is the symbol for the prefix. So if you're talking about, probably the most common English measurement we're familiar with is for distance, kilometer. So kilometer. We're measuring a distance, so that's the meter. And then we have a prefix, kilo. So this is the prefix. So you see our prefix here. So all these 2 tables are telling us is what is the prefix written out, and then what is it just if we wanted to write a symbol. So instead of kilo, we could write K. And then meter is what we're measuring. We're measuring a distance, and the symbol for that, you don't see it on this table because this table only deals with the prefixes, but the symbol for meter is M. So that's what the first 2 columns are telling you, just what is the prefix, and then rather than writing out the entire word exa, what symbol could we use instead? The second 2 columns are telling us in 2 different ways a certain number. So again, let's take a look at kilo. We want to know, what is this number telling us? And this is where it gets a little bit tricky. So here is our prefix, and here is the thing we're measuring, distance. If we dropped the word kilo, we would just have meter left. And if you have a unit of measure with no prefix, we call this the base unit. And you'll notice this grayed in row says base unit or basic unit. So what this table is telling us is we're looking at the kilometer, so km. This number 1000 is telling us how many of our base units does it take. So kilometer, we're taking away the prefix kilo and just using meter. How many of our base units does it take to make up 1 of these units? So this table is a little tricky to read because this number is right next to kilo, but it's actually talking back to the base unit. So let's do another example. So we looked at micro already. So if we're talking about, let's talk about micro seconds. That would be the Greek letter mu for micro, and then seconds is abbreviated with an S. The base unit would be simply seconds. Micro is right here. This number right here, or this number right here, they're the same thing. This is just written out in decimal form, and then this is an exponent form. So this number right here is telling you how many of the base units, seconds, for every 1 of this unit. Another thing to look at is whenever you have a conversion factor, so let's go back to this one as an example. Whenever you have a conversion factor like this, there's actually really 4 ways to write it. So this is our first way. 1 kilometer equals 1,000 meters. Let me rewrite that up here. 1 kilometer equals 1,000 meters. But I could have written, instead of 1,000, I could have written 10 to the third. So there's 2 ways to write it. But there's a third and fourth way. So let's take 1 kilometer equals 1,000 meters again. I'm going to divide both sides by 1,000. When I do that, 1 divided by 1,000, I end up with 0.001 kilometer. And then when I divide 1,000 divided by 1,000, I end up with 1 meter. And the reason you might want to do this is it simply changes where is the 1. So here you have 1 of your base unit. Up here we had 1,000 of our base units. So it's just in how you want to think about it. So there's the first 2 ways you can write these out. Here's the third way. And then the fourth way you can write that out is simply write this in exponent form. This would be 10 to the negative third. And it's up to you which way you prefer to work with it. And you might change your mind depending on the problem. All right, let's look at another example. A pill has a mass of 0.325 grams. We want to know, what is this in milligrams? So if you're looking back to the table, you would see that the prefix milli, it is right here, has the number 10 to the negative 3 associated with it. But that is how many of the base units. So that would be how many grams. And it's always per 1 of this other unit. So that's one way to write it. But if you do in your calculator 1 divided by 10 to the negative 3, what you'll see is you get 1,000 or 10 to the positive 3. So another way to write it is 10 to the positive 3, I'm not going to change my units in any way, milligrams for 1 gram. Either way is fine, you'll get to the same place. We cancel out here, we're left with milligrams, and our answer should be 325 milligrams. All right, let's take a look at another example. The shot size of an injection molding machine needs to be increased by 2 cc's. And cc stands for cubic centimeters. And this is an important thing to note. A cubic centimeter, you also sometimes write it like this, centimeters cubed. This is the same thing as a milliliter. All right. So we need to increase our shot size by 2 cubic centimeters, otherwise known as 2 milliliters. And we want to know, what is this in liters? There are 1,000 milliliters in a liter, or 10 to the third. So I'm going to go like that. 2 divided by 1,000, I get 0.002. All right, let's take a look at 2 last examples. We want to convert 0.002 kilometers to centimeters. Now notice, both of these have prefixes. So we are not converting into the base unit, which would be meters, or starting with the base unit, which would be meters, and then converting into something else. So there's a few ways you could approach this, but what I would suggest doing is take your kilometers and convert into the base unit of meters first. There are 1,000 or 10 to the 3 meters in a kilometer. Once you're in your base unit, then go to your other unit. We have meters here. We want to get rid of it, so it's going to go on the bottom to cancel, and then centimeters on top. There are 10 to the 2 centimeters and 1 meter. So when you multiply 0.002 times 1,000 times 100, you end up with 200 centimeters. Final example, convert 8,000 milliliters into deciliters. Again, we have a prefix here, a prefix here. So we're not starting with the base unit of liters, and we're not ending with the base unit of liters. But as a halfway point, I'm going to go into the base unit of liters, and then I'm going to go out of liters into deciliters. There are 1,000 or 10 to the 3rd milliliters in a liter, and then there are 10 deciliters in a liter. So when you do 8,000 divided by 1,000, you get 8, and then multiply by 10, you get 80 deciliters.